Hello. 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 Yeah, hi Arjun. How are you?
Hi, sir.
So are you able to see me on my screen?
Yes, I'm able to see you.
Okay, okay, that's okay, okay. Screen is also visible to you, no?
Yes, sir. Yes, the screen is visible
Okay,
to me.
okay, all right, all right.
Just give me some
Okay,
seconds, sir.
yeah, yeah, sure. Yeah, so shall I proceed on?
Hello.
Hello. Yes, Arjun, shall I proceed on?
Yes, sir. Yes, sir. You can proceed.
Okay, all right.
Am I
So,
audible?
yes, 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 you're audible. So we shall start with the electrostatics, right? Hello. Okay. So electrostatics we are starting with. Okay. So basically in the electrostatics, what all the topics we have to cover on. First of all, we will just make a list of those. Okay. So first of all, we have to cover the charges, right? Secondly, we have to cover the Coulomb's law. Okay. Next, we have to see is about the electric fields, right? Due to various things. Okay. Next, we have to see is about the dipoles. Correct. Next, fifth point we have to see is about the electric fields and the dipoles together. Okay, so dipoles in the electric field, in the electric fields. Correct. Next, we have to see is about the potentials. Okay, and potential differences due to various things. Okay, so these all are the topics that we have to cover up in the electrostatics. Okay, and somewhat we also have to see is the conductors and capacitors. Okay,
Yes, sir.
conductors and capacitors. That is also we have to look up. All right. So basically, first of all, we will going to start with the basic thing, that is the charges. Okay. All right. So can you let me know what are the charges?
Charge is a fundamental property of matter.
Absolutely correct. And what is it required? Due to which what is happening?
Due to which there are forces acting. There are forces acting between two particles, charged particles. There is
Absolutely
attraction or repulsion.
correct. 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 Okay. So due to which what is happening? They shows electrical effect. It is repulsion as well as attraction. Okay. So repulsion as well as attraction will be there due to this property. Okay. And the charged particle is the basic property by the virtue of which they can repel another charged particle or attract another charged particle, right? Another
Yes, sir.
charged particle. Correct. Next is what are the kinds of charges? There are, I think, two kinds of charges: positive charge, and the second one is the negative charge. Correct. So, what are
Yes,
the
sir.
impacts between now? So, what is happening? Well, similar charges will going to repel each other, like plus plus will going to repel.
Yes, sir.
Okay, and minus minus will going to repel like that.
Yes, sir.
Correct. And what about the opposite charges? Opposite will be attracting. So plus and minus, if you are having, they will be attracting to each other, right? So here I am having repulsion. Here also I am having Oh, just a second, Arjun. Okay.
Yes, sir. ಏನು ಏನಮ್ಮ ಇಲ್ಲ ನನಗೇನು ಬೇಡ ನಾನು ಬಿಸಿ ಇದ್ದೀನಿ ನನಗೇನು ಬೇಡ
Yes, hi Arjun.
ಹಾಯ್ ಸರ್
Yeah, actually, because of the power that will going to sleep. Okay. All right. So we'll be starting this back.
ಇಟ್ಸ್ ಓಕೆ ಸರ್
Okay. Okay. So are you able to see the screen?
ಎಸ್ ಸರ್
Okay. Okay. Just a second. Am I visible to you or not?
ಸರ್ ಯು ಆರ್ ನಾಟ್ ವಿಸಿಬಲ್ ಬಟ್ ದ ಬೋರ್ಡ್ ಇಸ್ ವಿಸಿಬಲ್
Okay. Okay. All right. No issues. Okay. No issues. Just a second. Okay. All right. So where were we? Yes, we were discussing about the charge properties. Okay. So positive charges will going to repel each other. Okay. Positive negative charges will going to attract and similar charges will going to repel. Correct. So this is what we have already seen. Correct. So plus plus repulsion, minus minus repulsion, and this is going to be attraction. Correct. Right.
ಎಸ್ ಸರ್
So next we have to see is about this is all about the charges. Okay. Next we have to see is about the properties of charges. Okay. So can you let me know what are the properties of charges? Mm-hmm. Properties of charges.
charges
Mm-hmm.
charges can neither be created nor can it be destroyed conservation of charge
Correct, correct. Conservation of charge means neither be created nor be destroyed. So first is the conservation of charge. That is, can neither be created nor be destroyed. Correct.
yes sir
Neither be created nor be destroyed. Okay. And next, just like that, suppose this is a body, right? And suppose if I pull out some charges from this body, okay, so this body will going to acquire the similar charge. Correct. So
yes sir
so what happens in this complete system? If I talk about this complete system, so for this complete system, the net charge will be 0. The net charge on the system will be 0.
zero
Right? So that is how we can conclude that charge can neither be created nor be destroyed. Correct.
yes sir
Okay. All right. Next property. What is the next property of charge?
next property is that
Mm-hmm.
velocity of this thing matter, or
Sorry.
charge does not change with the velocity of the body that that
Yeah,
contains
charge.
charge.
Yeah, charge cannot change with the velocity of the body or motion. Okay, so charge
Yes.
remains independent. Remains independent. Independent. In spite of with velocity, with the speed, or with motion. Okay, but motion, but the mass will going to change with the motion. Okay, okay, but the
Yes, sir.
mass will going to change. Will change with motion. Okay.
Yes,
So
sir.
how does the mass will going to change? Mass is equal to what? M naught is the rest mass upon under root of 1 minus v square upon c square. Correct. So this is how the mass will going to change with the motion, but the charge will not going to change with the motion.
Okay.
Correct.
Yes, sir.
What is the next property?
Next
Hmm.
property is
Mhm.
the common denomination should be one electron. That is,
Yeah, the
it
charge
cannot
is,
be half electron. Yes, sir.
yes. That is quantization of electric charge. That is
Uh,
quantization of electric charge. Correct. So what is quantization of electric charge? That is the charge on any body. See, if you want to take out the electrons from a body or charge from a body, so charge, how to charge a body? Basically, only electrons are responsible to charge a body, right?
yes,
So
sir.
we can say that for charging a body, because protons cannot be separated and neutrons can also not be separated from the nucleus. So we can say that only electrons are responsible uh, to charge a body. To charge a body. Correct. So only electrons are responsible to charge a body. So therefore, we can say that it cannot, proton and neutrons cannot be coming out. So now we have to you have to take out the electrons. So that electrons will be either 50 electrons, 40 electrons. Okay, that can be integer material, right? So they cannot be
Yes,
in the
sir.
form of fractions. Okay. So the charge on any body can be only the integral multiple of the charge on electron. The integral multiple of the charge on electron. Correct. That is Q must be equal to plus minus LE. Is that clear to you?
Yes, sir.
The charge on the body must be some integral multiple of charge on the electron. That is Q must be equal to plus minus Na. Correct. Where N belongs to integer. Right. So suppose this body is there. So suppose if you take out suppose 50 electron from this body to this body. So this is having deficiency of electrons. So it is acquiring, this body will going to acquire plus 50 electron charge. Correct. And this body will going to acquire minus 50 E charge. Correct. So this you know now what is the charge on a body? What is the value of electron charge on the electron? It is equal to minus 1.6 10 to the power minus 19 coulomb, and it is on the proton is plus 1.6 10 to the power minus 19 coulomb. Correct.
Yes, sir.
So next we will going to have is this. Hmm. So this is the quantization, and one more thing to be remembered is that the quantization is valid only for small charges, okay, not for the bigger charges, bigger bodies, because the
Yes,
bigger
sir.
bodies will going to have a charge of the order to the power 18 or 16. So if you take
Yes,
out
sir.
suppose 10 electron or 20 electrons, it will not have much impact on it. Okay,
Yeah.
so this is valid only for small microscopic particles.
Yes.
Okay, so quantization is valid only for microscopic particles, है ना? Correct.
Yes, sir.
And for macroscopic it is not valid. All right. Next property is the additive nature of charge. Okay, additive nature of charge. So what is the additive nature of charge?
Mm. Additive nature. I don't know, sir.
Suppose in a box, suppose you are having, this is skill equality basically. Okay, so if in a box you are having, suppose minus 2q charge, plus 5q charge, minus 9q charge. Okay, so total charge will be simply the sum of all the charges. Okay, that is minus 2q plus 5q minus 9q. Right, so that is going to be equal to what? Hmm, minus
minus 6 q.
minus 6. Correct. So it is a scalar quantity. So the charge on any body must be the only the algebraic sum of charge. All the charges given there. Okay. So this is the additivity of the charge. Okay. Additive nature of charge means this is scalar quantity. Add it up directly like that. Got it?
Yes, sir.
Okay. Next. Okay. So this is all about the properties of charges that we have already discussed over there. Okay. Charge can either be created or be destroyed. It is additivity. And what is the SI unit of charge?
Coulomb.
Yeah. SI unit will be coulombs. Okay, and it is a scalar quantity. So up to that clear, everything for
Yes,
about
sir.
the okay, all right. Next, one more property is that only repulsion is the true test of electrification. Suppose you are charging two bodies. Suppose these are two bodies, and you are going to charge this body. You want to charge this body. So there are certain methods of charging. So do you know what are the methods of charging?
Yes, sir. I know.
Charging. So what are the
Friction. We can charge by friction. We can charge by conduction, and
yeah,
also we can charge by induction.
yeah. So that is conduction, and the next one is third one is the induction. Correct. So friction, when you rub two bodies, one is acquiring positive charge and one is acquiring negative charge. Why? Because when you rub two bodies, then what happens? Some of the electrons will be distorted out from one body to another body, right?
Yes,
Like
sir.
glass and fur, examples we have read. Correct. So
Yes, sir.
glass will going to acquire positive charge and the fur will going to acquire a negative charge like that. Okay.
Yes,
Because
sir.
some electrons in the glass will comes to the fur. And conduction means to charge a body like that and to make a conduction with another body by conducting wire. So some charge will be transferred. So again, there will become Q1 dash, Q2 dash charges will be acquiring over there in both the bodies. Correct.
Yes, sir.
And induction means not direct contact. Okay. Induction means not because of direct contact. So these methods are clear to you. Shall I proceed
Yes,
further?
sir.
Or
Yes,
okay.
yes, sir.
This is all about charging. Okay. Next. Uh, Next we have to see is about the Coulombs force. So see, we will be covering the syllabus in accordance with the board also. Okay, so that whenever you want to revise that, so you can also have derivations with you. Okay, you are belong to CBSE board, right?
Yes, sir. State board, but it is very similar to CBSE board. Even we follow NCERT syllabus itself.
Okay, okay, all right, all right. So do you recommend any refreshers for that?
No, 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 nothing, sir.
Okay, only NCERT you are doing, right?
Yeah, same. NCERT itself.
Okay, so NCERT and
Just NCERT, nothing extra.
just
Only NCERT.
NCERT. Okay,
Yes,
okay.
sir.
For quick revision, you should just buy a book that is exam kit. Okay,
Exam kit.
exam kit, yeah, for
Okay.
physics. This is
Okay.
for
This is for which exam, sir?
exam kit. This is a Lakshmi publication book for CBSE exam. Okay,
Okay.
this is a Lakshmi publication. Okay, so that this is very good book for that.
Yes, sir.
Okay, so just buy if you it's possible for physics, just buy this book. Okay,
Mm. Yes, sir. I will buy the book.
all right. So next we will be seeing is about the Coulomb's law for the forces between the two charged particles. Suppose these two charged particles we are having Q1 and Q2, correct? And suppose they are separated by a distance r. Okay, so now what happens? Mhm. So they will be either repelling or they will be either attracting by a constant force, by same force, similar kind of force F. Okay, so these forces must be opposite to each other and equal in magnitude. Okay, according to Newton's third law, they will be equal in magnitude but opposite to the direction. Okay, so according to Coulomb, the force is proportional to product of charges Q1, Q2 and inversely proportional to the square of the distance between the two charges, that is r square. Correct. So combining
Yes.
these two equations, so F is proportional to Q1 Q2 by r square. So F is going to be equal to K Q1 Q2 by r square. Is that clear?
Yes, sir.
The force is going to be K Q1 Q2 by r square. Now if I talk about the K, so K is going to be equal to 1 upon 4 pi epsilon. Okay. And what is the epsilon? Epsilon is the electrical permeability of the medium. Electrical permeability of the medium. Correct. It is just similar that how much medium is capable or how much medium is effective to make this force. This is what decided by the epsilon. Okay. So it is the electrical permeability of the medium. It means that how much the medium is capable or how much the medium is effective to execute this force. All right. And there is also a term epsilon naught. Okay. This is the permeability for vacuum. Permeability for vacuum or air. Right. Correct. So epsilon naught
Yes,
is the
sir.
permeability for the vacuum of the air, and it has a value that is 9 to the power minus 12. Actual value is 8.85, right?
Okay.
So approximately its value is going to be 9 to the power minus 12.
Mm.
Correct.
Yes, sir.
And one more term we will define is the relative permeability. So relative permeability is what? Relative. Or we can say that dielectric constant. Dielectric constant. Correct. So relative permeability of dielectric constant, if I'm going to define, so that is epsilon r, or it can also be represented by k. So that is like equal to permeability of the medium upon permeability of free space or vacuum.
Yes,
Right.
sir.
So that is a ratio of permeability of medium and upon permeability of free space or vacuum.
Vacuum.
Correct. So this is how we can
Yes.
define this. Correct. So here we can say that epsilon can be equal to epsilon naught into k. Correct. So small k can be equal to 1 upon 4 pi epsilon. Right. Look at the
Yes, sir.
previous slide. Hmm. Epsilon can be equal to 1, k will be equal to 1 upon 4 pi epsilon small k. So now if I put up the value, hmm, so small k will be equal to 1 upon 4 pi epsilon, so that is equal to 1 upon 4 pi epsilon naught into k, capital K. Correct.
Yes,
And
sir.
if I talk about for air, if I talk about for air, so in air, k is going to be 1 for air. Okay. For
Mm.
water, k is going to be 81, right? A constant. So
Mm.
in air, if I talk about, so small k can be equal to 1 upon 4 pi epsilon naught only. Its value is 9 into the power 9. Correct.
Yes,
Its
sir.
value is 9 into the power 9. Like that. Okay.
Yes, sir.
So if I talk about, I'm going to give the force in air. So force in air can be equal to 1 upon 4 pi epsilon naught into Q1 Q2 by r square. And force in the medium can be equal to 1 upon 4 pi epsilon naught into k into
Okay.
Q1 Q2 by r square. Correct. Is this
Yes,
clear,
sir.
everyone? Okay, so this is how we can give these values. All right. So basically,
Yes.
this is how we can find out the force. And now there is some properties. There are some properties of force that we have to remember. That how does this force is acting? Okay, and how to apply the things. Okay, so there are certain properties of the force. So we look out that also. So next we have to see the properties of force. Are you writing something?
Hello.
Yeah, have you writing something?
Yes, sir. I've written all these already while revising, but as you proceed, I will write down.
No, it's okay, it's okay because I think we have less time left, so we will do it fastly. Okay.
It's okay, sir.
So
Now I can replay all these, right? If I want.
Yes, 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 you can replay it. You have the links now, so that link is capable to replay it whenever you want to replay.
So where I will replay it and again I'll take down, sir, so that
Sure, sure.
time is not wasted.
Correct, correct, correct. No issues in that. Okay. And one more thing I want to know is that how to cover up the maths. Means you are going to opt for maths also.
Ah, yes, sir. Mathematics, 12th standard was important for me because
Correct.
this calculus, I was very weak. I am very weak in calculus actually.
Okay, okay,
That's why I
okay.
was thinking of taking 12th standard mathematics and 12th standard physics. So
Okay,
when
okay.
are you planning to start 12th standard mathematics, sir?
To student mathematics, I will start in the afternoon words. Okay, because afternoons there some people are also interested to join. So in
Okay.
afternoon we will be covering. In afternoon we will be covering 12th mathematics. Okay.
Okay. When will we start? Like which day? Tomorrow, day after
Tomorrow,
tomorrow will
tomorrow,
we
tomorrow.
start?
Tomorrow I will start mathematics. Okay, no
Tomorrow
issues.
we'll start mathematics also.
Yeah, correct.
Okay, sir. You please inform me the timings and send me the link. I will just join the session.
Sure, sure, sure. No issues in that. Okay.
Yes, sir.
So properties of force, we can say that first property is that yeah, it follows Newton's third law. Correct? Newton's third law of Newton. What is third law? That is every
Every
action is equal to opposite
every
reaction.
force or every action has an equal and opposite reaction, and
Yeah, correct.
the
Mhm.
two forces are acting on the same
Different
body.
body, different
Sorry,
bodies.
different.
Yeah, and the forces acts on different bodies. Correct. So this is the most important thing. It means that one charge is having a force like that, so another charge will be having a force like that. So on the system, on the complete system, we can simply say that the net force is zero. Correct. So on the complete system, if we talk about, so net force on the system, this is what we can conclude, right?
Yes, sir.
And if net force on a system is zero, we can apply momentum conservation, right? So if they are capable to move, they are free to move. So if the charged particles are free to move, the charges are free to move. Okay. The momentum for the system remains constant. Correct.
Yes,
That
sir.
is, the initial momentum for the system is equal to final momentum for the system. Correct.
Yes,
Is this
sir.
clear to everyone? Okay. This is clear now. The initial
Yes, sir.
momentum of the system is equal to final momentum of the system, like that. Okay. Next. Next is what? Next property. Second property is that yeah, the force act along the line joining them. Okay. The force act along the line joining them. Correct. It means that suppose two charged particles are like that. So the force will be along it, like that and like that. Correct. Suppose two
Yes, sir.
particles are like that. So the force will be along it. Suppose they are, if one is plus and one is minus. So it will be like that and like that. Right?
Yes, sir.
Have you got it? The force will
Yes,
be
sir.
along the line joining them. Okay. And next is it is a conservative force. Third one is the electrostatic force is a static force is conservative. Have you got it? So
Yes,
it's
sir.
basically a conservative force in nature. Correct.
Yes, sir.
Okay. All right. Next. Next. And if so, suppose if any at any point more than one forces are there, suppose F1 vector, F2 vector, and F3 vector forces are acting like that. So the net force on the system on the particle will be given by the vector resultant, right? So F1 vector plus F2 vector plus and so on. Have you got it? So net force will going to be calculated like that. The vector
Yes,
resultant, okay? And do you know the vector resultant for two forces? That is A vector and B vector will be there at some angle theta. So the resultant will be given by what? Vector resultant is given by what? Like that. Okay,
Yeah.
resultant is given by what? Under root of A square plus B square
Plus
plus
2
2AB.
theta.
Okay, and like that we can give the vector resultant.
Yes. The root
Okay.
is for the whole this thing, right?
Yeah, correct. It is for the whole thing.
Yes, sir.
Okay. So can you try out some questions?
Yes, sir. Yes.
Just a second. So three charged particles I'm having Q, Q and Q, and they are placed on the vertices of an equilateral triangle ABC. Okay, so this is equilateral triangle of side A. Then find the force on C. Okay, so this is an equilateral triangle. Of side A.
Okay.
Please calculate.
One second, sir.
Yeah, have we got some answer?
1 second, sir.
Yeah,
Sir, root 3 k q square by a square.
yeah, absolutely. Because these both the one force is like that F1, and the second force is like that F2. This is applied by B, F1 is applied by A. Correct. So I think both will having the same magnitude. So magnitude wise, they both are equal. That is KQ by A square. And equilateral triangle, because that is angle is 60 degrees. So that angle is also 60 degrees. So if I take calculate, it's going to be F1 square plus F2 square plus twice of F1
2
F2 plus
cos theta.
60. Correct.
Yes.
So it is under root of square, the whole square plus KQ by A square plus twice of A F1 F2 is also KQ by A square square to cos 60 is 1 by 2.
1 by
Correct.
2. And
Yeah,
2
it
and 2
will be
will be
taken as
cancelled.
common.
Yes.
Yeah.
So
Like
root of
force
3 k q square by a square.
and root of 3 into kq square by a square.
Yes, sir.
Yeah, q square will be there. Okay, q1 q2 kq square, correct.
Yes, sir.
Okay, next question. Charges are there, q and q, equal charges. What are the charges placed there? Point q naught. And this is L, and this is also L.
Sir,
Find force on.
sir, the screen is struck actually.
Okay, just a second.
Yes, now it came. Now it came.
Okay,
Can you repeat the
so this
question
is
once
q
again?
and this is
Good.
also q. Yeah, these two charges are q and q. Okay, and this charge is q naught. Okay, so you have to find the force on the charge q naught. This distance is r, and these LL distances.
Sir, the angle is not given, right?
Yeah,
So how do we find out the angle?
see, you should just join it like that. Okay, and you should just join it like that. Okay, so
Yes,
I
sir.
think that side is going to be equal to root of r square plus l
L
square,
square.
and this is also going to be under root of r square plus l square. Correct.
Yes, sir.
So if I'm going to find out the forces, so here the forces will be like that. This is F1, and this Q will apply the force on Q naught like that. It is F2. Correct.
Yes, sir.
And this will be your axis like that. This will be your axis like that. Okay. So now what we will do is that we will take some angle. Okay. So let us take this angle to be theta. So this angle by symmetry will also be theta.
Yes, sir.
Correct. So this angle will be theta, and this is also theta by vertically opposite angles. Correct.
Yes, sir.
Okay, so now if we are going to find out the magnitude, so I think F1 is going to be equal to K Q naught divided by the distance ka square. So this distance ka square. So that is going to be r square plus l square under root ka square. So r square plus l square. Correct. So I think F2 will also be given by having the same distance, right, and same charges. So
Yes, sir.
magnitude will also equal to F2. Correct.
Yes.
So let us suppose that this can be equal to my F, right? So now I can take its component. So here I am having the component F1 sine theta. Here I am having F1 cos theta,
Yes, sir.
and F2 I am having here F2 sine theta, and on the upper side we are having F2 cos theta. Have you got it? So
So
these
if we
can be
change
cancelled out.
here, it will be
Yeah.
cancelled. Yes.
So net force will going to be equal to that is twice of F1 cos theta. Correct.
Ah,
So that is going to be equal to, because F1 and F2 are equal, so we can say that twice of F1 cos theta. That is twice of F1 is what? K Q naught
K
upon
Q naught by
r square
R
plus
square plus L
L
square.
square. Cos theta you can find from the triangle. This triangle cos theta can be equal to base upon hypotenuse, means r upon this, so r upon under root of r square plus l square. Correct? Correct. So it is
Yes, sir.
k q q naught r twice of k q q naught bar divided by r square plus l square to the power 3 by 2. Is that clear?
Yes, sir. Absolutely clear.
Yeah. So this is how we can find out the value of forces in the numericals. Okay. So
Yes, sir.
I hope you understand the basics, right? What are the basics behind that? How to apply the numerical forces on the numericals, right?
Yes, sir.
Okay. Next we will see is about the electric fields. Okay. So electric field, electric force, what is that? So it is the electric field is basically whenever we are having a charged particle. So these are the electric lines of forces are the hypothetical lines. Means we can say that this charge is producing some lines, and if some another charge is interacting in that, so because of these lines, another charge will going to interact with it. Means it will going to attract repel another charged particle now. So that attraction or repulsion will be governed by these fields, right? Plus charge will be like that, and field due to minus charges will going to be like that. Correct. So electric field is basically the force acting on the unit positive charge. Unit positive charge,
Charge.
yeah, placed at any point, placed at any point in the electric field. In the electric. Correct. So force acting on the unit positive charge placed at any point in the electric field is what is the electric field. At that point, electric field strength. Okay, we are talking about electric field strength. Intensity we are talking about. Okay, electric field strength or electric field intensity. Okay, so for that purpose, suppose if I'm going to find out the electric field due to a point charge. Okay, so electric field due to a point charge, I'm going to find out. Suppose the point charge q is there. Okay, so at point p we have to find out the fields. So fields will be outwards like that. So let us suppose this p is at a distance r. Okay, so now let us suppose a new charge q naught is placed there. Okay, so this will definitely applying some force on this q naught. So force on q naught at p is given by kq q naught by r square. Correct.
Yes, sir.
So force on unit charge means plus 1 is going to be 1 by q naught into kq q naught by r square. Correct.
Yes, sir.
So q naught cancelled out. So electric field at point P is what? It is the force on the unit positive charge, right? Equal to kq by r square. Have you got it?
Yes, sir. I got it.
So this force on that particular charge will going to be equal to kq by r square. Like that. Okay. And this is the force per unit charge. So the new unit will be Newton per coulombs. Newton per coulombs. Or it can also be volt per meter. There are two units, Newton per coulomb or volt per meter for electric fields. Okay,
Yes, sir.
and it depends only on the source charge. Okay, because Q is a source charge, na? So it depends only on the source charge.
Sir, why have you written 1 by Q naught there in force on uh, test one positive charge, unit positive charge?
See, in the previous field, if we talk about the force on the charge Q naught. Okay, so Q naught on the charge Q naught, we are having the force like that, na? So force on the
Yes, sir.
charge unit charge. Okay, so this is we known. So we are required for unit. Okay, so what we will do? We will divide it now.
Oh, okay, okay,
Correct. That is
okay.
when we divided it. So that will going to be like that kq by r square. Have you got it?
Yes, sir. Yes,
And it
sir.
is
I got
also
it.
a vector quantity. This is also a vector quantity. Okay. So suppose if at any point, suppose we are having lots of electric field, E1 vector, E2 vector, and E3 vector, like that. Okay. So net field is what? It is a vector resultant. It is E1 vector plus E2 vector plus, and so on. Correct. So you should just calculate the vector resultant of the fields. Okay. Is this clear?
Yes, sir. It's clear.
Okay, so we should try some numericals on this.
Yes, sir. Sure.
So suppose this is my square, and suppose the charges placed on it like that Q, 3Q, and 4Q. Okay, side is A. Then find the electric field at center. Find the electric field at the center. Yeah, you got the answer?
1 minute, sir.
Mhm. So let us suppose this distance will be smaller. Okay, this is smaller from the center to the vertex. Okay,
That
so
is A by root 2, sir.
sorry.
That is small r is equal to A by root 2, sir.
Yeah, correct. Small r is equal to A by root. Correct.
Sir, should I tell the magnitude or should I tell the direction also, sir?
Direction also is required.
Direction. 1 second,
So
sir.
here we are having the E1. Okay. Here I am having the E2. And here I am having the E3 because the positive is outward. Okay. And here I am having the E4. Correct. So E1 is going to be equal to what? KQ by R square. E2 is going to be equal to what? KQ 2KQ by R square. E3 is going to be what? 3KQ by R square. And E4 is going to be what?
4q kq by r square.
4 times of KQ by R square. Correct. So if I talk about at point O, I think E3 and E1 will be cancelling opposite to each other. So we are having the net on the E3. So it is E3 minus E2. It is E3 minus E2. And here I am having E4 minus E3 minus E1. Sorry, E3
3
minus
minus
E2.
1,
Yeah.
sir.
And here I am having E4 minus E2.
E2.
Yeah. So E3 minus E1. E3 minus E1, if I calculate, it will be 2 kq by r square, correct? By magnitude,
2 kq by r square.
correct? And this is going to be what? 2 kq by r square, correct? So the resultant will be like that. So they will be on 90 degrees, correct? Because for a square, diagonals bisect just 90 degrees. So E net will be here. So E net will be equal to under root of this square twice of kq by r square का whole square plus twice of kq by r square का whole square. So that is
Yes,
going
sir.
to be equal to root 2 kq by r square. We'll go only far here. So what we are having root 2 kq by r square means a square by 2.
Sir, what about theta?
Theta is 90 ना, तो cos theta will be cos 90 will be 0.
Yes, it will be 90. Oh, yes, yes, yes. Oh, okay, okay.
4
Sir.
root 2 kq by a square. Have you got it?
Yes, sir. I got it, sir.
Okay, okay, that's great. Okay, so all right, Arjun. So I will going to end up today here only. Okay, and tomorrow classes I will be covering the next topics. Okay, I will not tell you the messages. I will planning right now that how we will going to schedule that. Okay, so I will let you know in the
Yes,
morning. All right.
I, okay, okay, sir. I think tomorrow we'll
Okay,
be
okay,
able to finish this lesson, I think, right? Tomorrow or day
yes,
after tomorrow.
yes, yes, yes. We will going to do it as soon as possible. Okay.
Okay, and maths class, you just let me know tomorrow, sir. Tomorrow in the
Yes,
morning.
definitely. I will let you know about it.
Okay,
Okay.
sir. Okay. Thank you very much, sir. Bye. Good night.
Yeah, yeah. Have a good night.